It is a week 3 assignment of Database Management System NPTEL course, March 2019 paper of this assignment. Now coming to question number 1. It is given customer table, account table. Tables are given with some attributes. And there are two questions are given in the question 1. This is the first question, Roman number 1. First question is find out the phone number and address of the customers. Find phone number and address. Means phone number and address are the columns. Columns can be selected in algebra using pi operator. Which columns that you want in the output, you have to specify as a subscript. Okay, phone number, comma, address, both you want in the output. You have to specify as a subscript. Named by Aditya is a condition Aditya. The conditions you have to write using a selection operator sigma. What is a condition name equaled Aditya? Name equaled Aditya in relational algebra from the above database scheme. Here friends, I am introducing two operator. One is pi, the column selection, and sigma for row selection. For row selection we should use sigma. For column selection we use pi. And according to the statement given, we need to have these two conditions. This one, this one. Look at option A. Sigma name equal to Aditya. Pi name comma phone number comma address. And anyhow name is not required. It is incorrect. And moreover, this query is also syntactically incorrect. Why? Because in relational algebra, always first relation means table is required. From the table, it requires to select the rows. We use sigma. From the rows selected, next we should use columns. Pi. Columns. This is order of execution. Means first table, and rows, then columns. This is an order of execution. So that first table, then rows means sigma it is required, but it is given pi, then sigma given, it is incorrect representation. Now option B, pi phone number comma address. This is correct. This is required, correctly represented. And what is the condition? Sigma name equal to Aditya from customer. So B is perfectly right. And friends, look why other options are wrong. It is syntactically incorrect. And here sigma name equal to Aditya is mentioned at the outer of this expression. And here actually evaluation will be done from the inner to outer. Means first this one is to be executed. Means from the customer it is selecting phone number comma address. Only phone number column address. From the result it is selecting those tuples where name equal to Aditya. So what is the result of this query? Contains only phone number comma address but not name. So which is syntactically incorrect. That's what I said, syntactically incorrect. That's what it is recommended to go the order table, rows, columns. Option D is incorrect. Why? Because here it is used sigma. And not sigma, it is a row operator. It is called row operator. We call rename operator. This is incorrect. And in the same question, there is one more question. Find account number and branch name. Means pi, account number, comma, branch name, columns. Those accounts where the balance is less than 1000. Balance is less than 1000. Means here sigma. Balance less than 1000. These are the conditions. Check fastly the options. Option A, account number, comma, branch. It is correct. Sigma balance less than 1000 correct. Account correct. Option A is correct. Option B, account number comma balance, but question is account number comma branch but not balance. Incorrect. Sigma balance less than 1000, it should not be, it should be in the inner. So it is incorrect. It is incorrect with the same reason. So answer for this second part of question 1 is option A. Coming to question number 2. Consider the schema of relation shown below and the SQL query that follow. Here these are the three tables are given. Student, courses, grades, and a SQL query is given. Question is which of the following sets is computed by the above query. Here you observe this query is on students, courses, grades, and all three tables are in the from class, so that it performs a Cartesian product between student, courses and grades. From the Cartesian product, it is going to select the tuples satisfying the conditions students dot roll number equal to grades dot roll number. I am calling this is first condition. Courses dot instructor equal to course, second condition. Courses dot course number equal to grades dot course number, third condition. And grades dot grade equal to A, fourth condition. And here instructor is there in the course table with a condition that name of the instructor should be course. And grades equal to A, grade is there in the grade table, that grade is A, this is a one condition. And here first and third conditions are joint conditions, roll number equal to roll number, it means this roll number and this roll number is combined, and course number equal to course number, that is a condition 3, these two. Okay, here there are certain options are given and we have to find which option is correct. Now look for all the three tables and these are the conditions I have written, and here option A given names of students who have got an A grade, because condition 4 says who have got an A grade in all courses taught by course. Course condition is there, grade A condition is there, and this query says joining of all the three tables, because joining of all the three tables is there, so and it is finding name of the students and it is okay. But we have to think about this keyword all, whether it is all or some, we have to decide. Option B, look, name of students who have got an A grade in all courses, but here in option B the instructor name course condition nowhere mentioned, because nowhere mentioned option B is incorrect. Option C, names of students who have got an A grade in at least one of the courses taught by course. So what we wanted, name of the students who have got A grade, that is a condition 4 is already there, and in at least one of the courses taught by course is a second condition, that is also satisfying. And D is none of the above. And anyhow, with this understanding I eliminated option B. Now I have to see whether option A or option C is correct. In option A and option C, this condition 4 grade A and instructor course, that is a condition 2, is satisfying. In both of them names are selected, and but only this option A and option C differs with respect to at least one and all of them, at least one and all of them. Now see, there is some student, a table I am taking with roll number, name are the attributes, roll number comma name are the attributes. Now what were the roll number? 1 name A, roll number 2 name B. Okay, roll number 2 name B. And we have a table called grades. In the grades table we have roll number, course number. Okay, and I'm assuming the grades are for A grades only, because in options that it is given A grades, and here the condition is also A grade. I'm assuming all grades are A grades only, and some grades are B grades anyhow that are not going to be selected. That's why I'm not writing grade here. And one more table is courses. And courses having attributes course number and course name. Okay, name, course name. Just I'm writing ME for specifying course name. See, rule number 1 enrolled for course number 9, and course name and instructor. Here I will be showing instructor, means here I wanted to take instructor. Instructor is course. Here option A given all courses, option C given at least one course is taught by course. Chalo, I'm assuming course is teaching course number 9 and course number 10, assuming case. And student 1A enrolled for a course taught by course, not all the courses. Student 2B enrolled for one course taught by course, and student 3C enrolled some course 11 which is not taught by course, it is taught by some other person, say Ramakrishna R. Now check for the conditions. First condition is roll number equal to roll number. Second condition course, here because second condition is course, this is true, anyhow this is not going to satisfy the second condition. And fourth condition, grade C, here just I'm assuming it is grade A, it is grade A, it is grade, all are grade A only I have taken, okay, grade A, or else I'll be taking grade B. So because if it is grade B, this tuple also not participating in the output. And what are the next two conditions? Next two conditions are condition 1 and condition 2, that is roll number equal roll number. Here 1 equal to 1, true, this is one combination, and course number equal to course number, that is the third condition. 9 equal to 9, true. So means this is one mapping, this is one mapping. In this one mapping, satisfying the conditions, roll number equal to roll number, course number equal to course number, grade A, and instructor name course, satisfying. So that it is displaying name attribute in the output, that is A, means A is a student who got an A grade in a course taught by a course. But course is teaching two courses. But is student 1 got A grade in every course taught by student, every course taught by course? No. So that this is not going to find names of students who have got A grade in all courses. Why? Because you are getting A in the output even though A not got A grade in every course taught by course. Suppose if I have 1 and got B grade in the course number 10. Here also you see 1 equal to 1 matches. Here 10 equal to 10 matches. Instructor is course matches. But grade is B not matches. Because it is not matches, this combination is incorrect. So can you expect this A? No. So means this A not got A grade in all courses taught by a course. So that answer for this question is option C. Why? Because it is at least one and it need not be all. So that option C is the correct answer. Option A is incorrect. So that answer for the question is option C. Question number 3. Find out the account details where the balance is greater than 5,000. Both tuple and domain relational calculus, means both TRC, DRC. We have to find the account details, means all the attributes of account table, with the condition that balance is greater than 5,000. Now, what is the format of tuple relational calculus? T such that P of T, where T is a tuple variable and P of T is called formula representing the TRC query T. And domain relational calculus has a form that domain variable 1, 2, dash dash, such that P of conditions on the domain variables x1, x2, dash dash dash. It is called formula. This is a format for TRC. This is format for DRC. Now look at option A, T such that T belongs to account and balance should be greater than 5,000. This condition is true, but between these two we should use a conjunction operator but not disjunction operator. So means usage is incorrect, it should be AND. So option A directly I am saying wrong. Now option B. Option B is also directly wrong. Here why? Because it is using conjunction but not disjunction. And friends, here conjunction will be like this, but here it is taken as a union operator and intersection operator. But because we don't have none of the above options, so we have to treat this union as a disjunction and this intersection as a conjunction. This is an assumption only. Okay. Option C, T such that T belongs to account and T balance is greater than 5,000. So okay, option C, this is correct. And here ABC such that ABC belongs to account. Again, this is union, means disjunction it is used, but actually it should be used conjunction. So option C is incorrect. So what is left is option D, that is correct. Here it uses conjunction, here also it uses conjunction, and conditions balance greater than 5,000 is true for both of them. So answer for this question is option D. Question number 4. From within a host language. What is a host language? A language to which SQL queries are embedded is referred to as host language. Means I wanted to embed SQL syntaxes into a Java programming language, then I can call Java is a host language. Okay. Select the correct embedded SQL query. Select the correct embedded SQL query to find the names of all instructors. Names of all instructors. Name we want in the output. whose salary is between minimum salary and maximum salary declared in the host language. So it means this minimum salary and maximum salary are the host language variables. In embedded SQL, the host language variables are preceded with a colon. So means we should use colon min salary and we should use colon max salary. Colon max salary. And here the question is whose salary is between min salary and max salary. Because between min salary and max salary, it is to use a between and operator. Between min salary colon and colon max salary. Okay, this should be selected. This between and operator we can also implement using min salary greater than or equals to some value. Okay, means salary should be greater than or equal to min salary and salary should be less than or equal to colon max salary. So between and operator can be implemented using this way also. This is required. And embedded SQL queries always had a syntax exec SQL and SQL statements with end exec. This is a syntax for embedded SQL query statements. This is a syntax. So means friends, you observe it should follow the syntax and it should follow the syntax of the host language variables preceded with the colon. And because question is to verify the salary between min salary and max salary, we should use between and operator, or we can use this kind of expression. These things you check in the options. Look for option A, exec SQL and exec SQL. Syntax is true. Its syntax is correct. Option B is incorrect because it is not following the syntax. Because I said embedded SQL queries will follow the syntax that starts with exec SQL and list of SQL statements and end with end underscore exec. Because it is violating the syntax, option B is wrong. And look for option D. Option D is directly wrong. Why? Because here min salary and max salary are the host language variables. Host language variables is to be preceded with a colon, but here colon is missing, so option D is incorrect. Now we have to look for option A and C. exec SQL and exec, exec SQL and exec. Both are correctly representing the syntax. And what is the query name we want in the output? Here also name we want in the output from instructor. Here is instructor, here is instructor. And salary between and operator is used. It is perfectly correct. It is correct. So option A is correct. But look for option C. Salary greater than or equal to min salary. Means it is following the second way of representing the between and operator. And salary less than or equal to max salary. So answer for this question 4 is both option A and option C. Coming to question number 5. Here a loan relation is given. Question is find out the loan details for branch name Alipur. Branch name Alipur. This is one condition. And loan amount is greater than 5,000. This is another condition. Loan amount greater than 5,000. In tuple relational calculus, it is a TRC expression. Now, the format of TRC expression is T such that P of T and T is a tuple variable, P of T is a formula. What formula should contain the conditions that branch name is Alipur, amount is greater than 5,000. And what we want in the output? All the loans we want in the output. Look for option A. T such that T belongs to loan, means my result T is belonging to the attributes of loan. Here it is used union. Actually it should be used as a conjunction operator, means this one is to be used. But here friends, observe union is used for representing the disjunction operator. And intersection is used for representing the conjunction operator. But between the two conditions we have to use conjunction but not disjunction. Option A wrong. Option D is also wrong because here also it is using disjunction. What is required? Conjunction. What is the condition? T branch name equal to Alipur. Between the two conditions we should use conjunction but not disjunction. So option B is wrong. So what is left? Option C. Option C is the correct option. Why? Because T is my result. That result is belonging to the loan relation such that the condition branch name equal to Alipur, and this is we call and the loan amount is greater than 5,000. It is perfectly right. So answer for the question 5 is option C. Question number 6. Map the given ER model into relational model in context of many-to-many relationship. And here employee and project participating with many-to-many relationship, and between them we have a total participation. If it is many-to-many relationship, we have to have one table for employee, one table for project, one table for works. So means this is to be represented with 3 tables. In all the three tables, we see what are the attributes. Employee will have an attributes gender, date of joining, employee name, SSN, DOB, salary, and SSN is a key attribute. And project having an attributes P number, P name, location, and P number is a primary key. Now we have to define the table for works. What is works? Works is a relationship between employee and project. So to show the relationship, the works table should contain the primary keys of the participating tables. Now what is a participating table? Employee and project. Their primary keys I wanted in the works on table. So employee primary key is SSN. Project primary key is P number. And works on is having its own attribute hours. We call it is a descriptive attribute. Which is describing the relationship. So because works on having their own attribute hours, so that hours also should be there in the output. Means that hours also there in the attribute of a table. Now what is the primary key for works on? The works on should have a primary key which is a combination of SSN and P number. And individually SSN is a foreign key, refers to employee table. P number is a foreign key, refers to project table. This is a table you can expect as a result of translating ER model to relational model. Now coming to the option A. Works on SSN hours. It is not showing P number, means it is not showing relation with project. Option A wrong. Works on SSN P number hours. The combination of SSN and P number given clearly a primary key. Now B is a correct option. Option C works on EMP name, SSN, P number, gender and all attributes are represented. But works on is a relationship between employee and project, and we have a cardinality M and N. Because cardinality is M and N, all 3 tables means employee, works and project you cannot combine. And you have to represent employee, project and works on as a separate tables. But here option C shows single table, incorrect. Works on SSN P number, this is correct. But works on is also having its own descriptive attribute, which is describing the relationship hours. This attribute is not shown in the option D, that's why option D is incorrect. So answer for this question is option B. Question number 7. Here it is given ER model having 2 entities E1, E2. Between them we have a relationship R. And observe friends, here is a single line, says partial participation. Here is a double line. This double line indicates total participation, right? Now question is, what is the correct notation for the above ER diagram? Partial participation of E2 in R. But E2, from E2 we have a double line, we call total participation. So option A is wrong. Total participation of E2 in R. Yes, E2 is totally participating in R. B is correct. C. Total participation of E1 in R. From E1 we have single line. Means it is a partial participation. But not total participation. C is wrong. Option D says partial participation of E1 in R. What is participation of E1? Partial. So D is correct. So answer for this question is both B and D. Question number 8. What constraints do the partial key and identifying relationship of weak entity type specify in this diagram? Partial key, which is there in the weak entity set. Here you observe friends, it is double rectangle. Double rectangle is for weak entity set. Identifying relationship. This relationship we call identifying relationship. identifying relationship represented with double diamond. We call it as identifying relationship. So here the question is, what is the relationship between weak and identifying relationship is the question. Now observe, weak and identifying relation means bank branch and branches relationship. Here what it shows, a bank, each bank may have n number of branches, correct? Each bank may have n number of branches. It is possible that one bank may have n number of branches, but you read from this side, each bank branch belonging to one bank, each bank branch belonging to one branch. So you have to read in this way, bank should have n number of branches, each branch is belonging to one bank. Okay, we should read in this way. Now because each bank branch belonging to one bank means bank branch uniquely determining the bank. Here we call it key constraint from this. So it means one bank branch should have one association with the bank. Now what options are given? Total participation with ratio 1 to n. Now it is total participation anyhow given. 1 to n means one bank branch belonging to many branches. But is it one bank branch belongs to many branches? No, it is incorrect. Partial participation, it is directly incorrect. Partial participation, directly incorrect. Why? Because this weak entity set is totally participating. So what is left is the answer. That is total participation with ratio n to 1. N to 1 means n number of bank branches belonging to one bank. That is option C. Question number 9. The create trigger statement. The create trigger statement is used to create trigger the dash. Here some dash is given. The dash class specifies the table name on which the trigger is to be attached. The dash specifies this is an after inserted trigger. This is an after inserted trigger. Okay. Now identify the correct options for the gaps in the above sentence. Here the question is about a trigger. Now what is a trigger? A trigger is a statement that is executed automatically. That is going to be executed automatically by the system. It is to be executed automatically by the system as a side effect of a modification to the database. Means if some action is to be taken on update, on insert, on delete of a particular row of a table, on a particular table, some action is to be executed automatically. Such actions we write in the trigger. That's why triggers are called event driven programs. We call it as event driven programs. So means it will wait for some event to occur. After some event occurs, these programs get executed. Here the event in the sense like insert, update, delete events, we can say delete events. And what is the syntax for trigger? Now syntax for creating trigger is create trigger, create or replace trigger. Trigger is a database object. We have to specify name of the trigger, after some action, after or before. We can use it either after or before some action executed, after or before some action like insert or delete or update. On table name, you have to specify the table name. Okay, on table name. It is possible to specify on a particular attribute also. Now we'll check. Identify the correct options for the gaps given below. Option A given for insert. For insert, we should not use. Why? Because the dash class specifies the table name. The table name is to be specified with which one? On class. So means what should be there in that first gap? On, not for. So option A wrong. Option B on, correct. Option B correct. The second gap is the dash specifies that this is an after insertion. This is an after insertion. So here we have to use for to specify after insertion. It is not that just insert we should use. It is none of the above is also not concerned. So we have to use for insert. So means for insert on a table, like here for insert, like we can say create trigger, name of the trigger, for insert or delete or update on table name. So answer for this question is option B, we use. Question number 10. Some ER model is given having employee. This is hierarchical relationship is shown. Employee may be secretary, technician or engineer. Employee may be salary employee or hourly employee. Some classification is there. Now question is, what constraint will be applied on the question mark? On this question mark, what constraint we have to show? Here, salaried employee, hourly employee. Here if I assume it is overlap constraint, it means an employee works on both salary as well as hourly employee. Actually, ER model is to show a real world representation. An employee either works on hourly basis or may works on salary basis, but not both. So that I cannot say that overlap constraint is incorrect. If it is overlap constraint means an employee who works on salary basis, he may also works on hourly basis. But generally it is not practical, so option E is wrong. So that we can go with option B. Why? Because an employee should work either on hourly basis or on salary basis. And it means these are two disjoint entities. Such constraint is called disjoint constraint. Okay, we can call it is a disjoint constraint. It means an employee who are there in salary section should not be there in hourly section. An employee who works on hourly section should not be there on the salary section. So we can go with an option disjoint constraint. And actually speaking, we don't have some names like specific constraint, multiple constraints. Such words are not there. These are given only to confuse you. So answer for this question is option B, that is disjoint constraint. Here, what is a real world situation? We assumed that an employee who works on hourly basis may not works on salary and vice versa. That's why we conclude with an option B.